In this video, you will become an expert at evaluating the 6 trigonometric functions and how to solve a right triangle for missing parts given at least 2 and the right angle. So first, let's look at what we have to have in order to be able to use our trig functions. We have to have a right triangle. If we don't have a right angle, we can't do anything we're going to talk about in this video. Second, theta, the angle that we're solving for or using in our functions, cannot ever be the right angle. Theta must always be an acute angle. We also want to remember that the sum of 3 angles of a triangle is 180 degrees. You also want to remember that the right angle accounts for 90 degrees of that 180. So right here in our diagram, this little square in the corner means that this is a right angle. Always opposite the right angle is a side that we call the hypotenuse. The other 2 sides we just call legs. Now, theta can be either of these acute angles. If we made theta the angle in the bottom left corner, the side opposite it would be this leg 2. The side adjacent to theta, so next to, would be leg 1. But notice, if I make theta this angle in the upper right corner, the side opposite it is leg 1. And the side adjacent to theta, next to it, would be leg 2. The hypotenuse stayed the hypotenuse every time because, again, it has to be opposite the right angle. The opposite and the adjacent legs will be changing. So let's now review the 6 trig functions. For sine, cosine, and tangent, you might remember something called SOHCAHTOA from geometry. Basically, in sine, the SOA, the O in the numerator stands for the opposite side length, and the H stands for the hypotenuse. In cosine, the CA, the A stands for the adjacent side length, and again the H stands for the hypotenuse. In the TOA, tangent, O again stands for the opposite side length, and A the adjacent side length. Cosecant, secant, and cotangent are all reciprocal identities with the one above. Reciprocal just means we flip-flop. And so in the cosecant, I want to divide the hypotenuse by the opposite side length. Secant is the hypotenuse divided by the adjacent side length. And cotangent is the adjacent side divided by the opposite side. We also want to take a look at Pythagorean theorem. Pythagorean theorem basically is just you want the hypotenuse squared. So usually we call that c squared. And that has to equal the other 2 legs squared and added together. Usually you call that a squared and b squared. We'll be using both SOHCAHTOA and the Pythagorean theorem today. Let's now take a look at examples A and B. In example A, angle C is our right angle, and that's going to make this side here, which we would call side C, the length of 7, our hypotenuse. I also want to point out that theta is up here at angle A. Since theta is at angle A, the side opposite theta, which we would call side A, the one between angles C and B, is going to be my opposite side. And so that only leaves me the length of 4, which we would call side B. That must be adjacent to theta. Now, I know the length of the hypotenuse and the adjacent side. Right now, I don't know the length of the opposite side. So this is where I'm going to use Pythagorean theorem. I can use Pythagorean theorem to solve for the third side of a right triangle if I know the other two. So again, we want to start with the hypotenuse squared. And that's going to equal the other two side lengths, the 4 squared plus the side I don't know, a squared. So if I go ahead and simplify this, I have 49 equals 16 plus a squared. If I subtract 16 from each side, I get 33 equals a squared. And when I take the square root of each side to get just a, I can't simplify square root of 33, and so I'm going to leave it square root 33. If you could simplify your radical, you are expected to. Now that we know all three side lengths of the triangle, we just have to use our SOHCAHTOA to figure out the 6 trig functions. So sine, that again would be the opposite over the hypotenuse. My opposite side length we just solved to be root 33, and the hypotenuse we were given to be 7. Again, if this fraction would simplify, I would want to do that, but this time it doesn't. For cosine, that's the adjacent over the hypotenuse. My adjacent side length I was given to be 4, and again, I was also given the hypotenuse to be 7. If 4/7 simplified, I would want to do that. Lastly, tangent is opposite over adjacent, and so since I was solved for the opposite side length to be root 33 and was given the adjacent side length of 4, I get root 33 over 4. Again, if it simplified, I would want to do that. For the reciprocals, all I have to do is really flip the numerator and the denominator. Now for cosecant, the reciprocal of sine, that gives me 7 over root 33. It's never proper to leave a radical in the denominator, so I have to rationalize the denominator by multiplying the numerator and the denominator by the square root of 33. That's going to simplify to 7 root 33 over 33. For secant, flipping 4/7 and getting 7/4, that's already simplified, so I'm done. But cotangent, the reciprocal of root 33 over 4, is 4 over root 33. So again, I have to rationalize my denominator, giving me 4 root 33 over 33. Again, if any of these fractions ever simplify, you need to do that. Please now pause the video and do example B. Here you'll notice that I actually did Pythagorean theorem 2 different ways. There's a reason for that. The original values that I was given for the side opposite theta of 9 and the adjacent side to theta 12, I noticed were both divisible by a common factor of 3, a GCF of 3. If I took that GCF out, I was really left with an opposite side length of 3 and an adjacent side length of 4. When I do Pythagorean theorem with the 3 and the 4, I have a much simpler radical to simplify. If I do it with the 9 and the 12, I have a bigger radical to simplify. And when I'm figuring out my trig functions, if I do the 9 divided by 15, I'm going to have to simplify that fraction every time. But if I just use the 3 and the 5, now I have a simplified fraction already. So it saves me time when I'm trying to simplify my radical and when I'm doing my 6 trig functions. Let's now take a look at examples C and D. First thing that you'll notice in examples C and D is that you are not given a picture. You're not even given what sides are what. That's something that you have to figure out. So every single time I would start by drawing a picture. Now again, we're told that theta is going to be an acute angle of a right triangle. So I would start with that. Next thing that I would do is I would look at the function that I'm given. I see that I'm given secant. Secant, if you remember, is reciprocal with cosine. Since cosine is adjacent over a hypotenuse, secant must be the hypotenuse over the adjacent side. And so what that means is that the hypotenuse is a length of 26 and the adjacent side is a length of 10. Now again, just like in example B, I'm noticing that I could simplify this fraction. I'm going to want to do that to reduce, to make my Pythagorean theorem simpler and my 6 trig functions simpler. So now that we know that it should be a hypotenuse of 13, go ahead and label our hypotenuse of 13. And let's also label our adjacent side with a length of 5. I'm still going to have to do Pythagorean theorem to figure out my opposite side. So let's go ahead and do that. So I have the hypotenuse squared equals the opposite side, which I don't know, plus the adjacent side squared. So if I start simplifying, 13 squared is 169, and that's going to equal a squared plus 25. If I subtract 25 from each side, 144 equals a squared, and again, taking the square root of each side, square root of 144 is 12. Now that I know that the opposite side is a length of 12, I can go ahead and do my 6 trig functions. Opposite over hypotenuse is sine, so I need to do 12 over hypotenuse of 13. For cosine, it's the adjacent side of 5 over the hypotenuse of 13. For tangent, it's the opposite over the adjacent. Notice, because I use the reduced side lengths, I don't have to simplify any of my fractions. Now for the reciprocals, we have 13 over 12 for cosecant. Secant they gave me, but again I might as well write it out simplified, 13 over 5. And cotangent will be 5 over 12. Please now pause the video and do example D. Here we were given sine, which was the opposite side over the hypotenuse. So that meant my side opposite theta was a length of 5, and my hypotenuse, the side opposite the right angle, was a length of 6. I had to do Pythagorean theorem to solve for my adjacent side. Since square root 11 did not simplify, that's what I left it. Then again, I used the SOHCAHTOA to figure out my sine, cosine, and tangent, rationalizing the denominator when necessary, and then the reciprocals for cosecant, secant, and cotangent. Again, rationalizing the denominator when necessary. Let's now look at the examples on the next page. Next, we want to be able to solve triangles for 3 missing parts given an acute angle measure and a side length. The 3 missing parts we need to find is the other acute angle and the other 2 sides. So let's start with finding the missing acute angle. If you recall, we said that the 3 angles of a triangle are going to total 180 degrees. So if you start with the 180 degrees and subtract out the 2 measures you know, the 90-degree angle and the acute angle you were given, you should be left with the measure of your missing angle. So here, the measure of angle T is going to be 62 degrees. Next, we want to find our missing side lengths. First thing I would do is start with the angle they gave me and call that theta. From here, we should be able to name our opposite and our adjacent side lengths. So the side opposite theta here is side S. The side next to theta, the adjacent, is side T. And again, the hypotenuse, the one opposite our right angle, is going to be side R. When you're trying to find a certain side, you want to ask yourself, what do you want and what side do you know? So if we start with side S, side S is the opposite side, so that's what I want. The only side length that I know is the adjacent side length, side T of 15. At this point, I think about my SOHCAHTOA, and I ask which of the three functions has these two sides, the opposite and the adjacent. Since tangent does, that tells me I want to use the tangent function to solve for side S. Then I fill in what I know. Theta, remember we said, was the 28-degree angle. So I'm taking the tangent of 28 degrees. Then I want to know the opposite side, side S, and I already know the adjacent side. That's 15. From here, I just have to solve and put it in my calculator. I would recommend we make this a proportion so that we can cross multiply. By doing that, that tells me S is going to be 15 times the tangent of 28 degrees. Now the first thing I'm going to want to check before I even do any calculations is my mode. I am trying to take the tangent of 28 degrees. So if degree is not highlighted when you press your mode button, you would need to scroll down, scroll over to degree, and press enter. If you're not in the degree mode, all of your answers will come out wrong. Now that I'm in the degree mode, I can do 15 times the tangent of 28. Enter. You're almost always going to get a decimal, and so just round that decimal to the nearest thousandth, which again is 3 decimal places. So here it looks like S is about a 7.976. Next, let's solve for side R. So again, I want to ask myself, what side do I want? The hypotenuse. And what side do we know? Technically we know 2, but remember, this was a rounded answer, so I prefer not to use it. So let's just say I only know the adjacent side. So looking again at my 3 functions, cosine uses both the adjacent and the hypotenuse. And so that's the function I would want to use to solve for side R. So again, I want to plug in what I know. Theta we said was 28 degrees. The adjacent side is a length of 15. The hypotenuse is again what I don't know, side R. Now you notice here, when I make this proportion and cross multiply, R is not isolated. So to get R isolated, since it's being multiplied by the cosine of 28, I'm going to have to divide both sides by the cosine of 28 degrees. So R should be 15 divided by the cosine of 28 degrees. If we put that in our calculator, I'm going to do 15 divided by cosine of 28. Looks like we're going to get about a 16.989. Now, to check our answers, again, this one I don't think we're going to have any problems with. These are the 2 that we might have problems with. You can always do your Pythagorean theorem very fast in your calculator. Now again, it's not going to work out perfect, but it should be very close. If I take my 2 legs, the 15 plus our side S, the 7.976, and square them, I should get about the same decimal as if I squared my hypotenuse. And if you notice, they are very, very close. That tells me that I most likely did this correct. Please now pause the video. Figure out the missing acute angle inside F. Figure out what trig functions you're going to use to solve for the two missing sides. We'll review that before we actually plug in and go ahead and solve. So here we found the measure of angle D to be 60 degrees. Since side D is the adjacent side and we were given the hypotenuse, the function that uses adjacent and hypotenuse is cosine. And so I'm going to plug everything into this ratio. For side F, that was the opposite side, but again we were given the hypotenuse. The sine function uses the opposite in the hypotenuse, so I'm going to plug everything into here and solve. Please again pause the video and solve each function. Please now check your calculations. When you agree, pause the video again and complete all of example G. Please check your answers for example G. When you are finished and agree, you may go on to tonight's homework.